Saxon Algebra 2, Lesson 47. Greetings, my students. We've got a two-parter. The first one is rate unit conversions, and the second part is algebra. But it's kind of like saying we're having two things for dinner. One is a meatloaf stuffed full of vegetables and potatoes, and the other thing we're having is ice cream. I mean, there's a metaphor for you. But don't worry, we're handling the more complicated things first. Rate unit conversions. What? We know what unit conversions are. We've been doing that for a long time. Several of you have told me you think they're easy. But this time, we're going to convert rates. Huh? What does that mean? Let's find out. I promise you, when you get the hang of these, and they're not too hard, they're just complicated looking, you're going to feel really smart. You're going to be bragging to your friends. Use unit multipliers to convert, ready? 42 inches per second. 42 inches per second. Notice instead of per, where the word per. Yikes. This is the word per. I turned it into a line because it means a fraction or a rate. 2 miles per hour. Starting units, ending units. The line says per. Miles per hour, inches per second. How are we going to do this? It's fun. First, we're going to convert the top. We're going to go from inches to miles. How do we do that? Well, let's see. First, we're going to go from inches to feet, right? A foot is bigger than an inch. There are 12 inches in a foot. Now we've got it stated in feet. Okay, now we're going to go from feet to miles because that's where we want to end up. Feet down here, miles up here. A mile is bigger, so it gets the one. This is 5280. Please make sure you have those conversion numbers memorized. Feet cancel, and we have now translated our beginning unit of inches to miles, which is exactly where we want to be. We're halfway done with the problem. Now what we have to do is convert seconds to hours. And guess what we're going to do? It's the very same process, only we do it kind of upside down. So look. We're in seconds. We need to go to hours. Let me just do this. This was feet to inches. No, I'm sorry, I said that wrong. This was inches to feet, and this was feet to miles. Okay, so both of these we're doing the top. Now we want to go from seconds to hours. Let's pretend that we need to go to minutes in between. You might be able to do it without that. We're going to go from seconds to minutes, and then over here, we're going to go from minutes to hours. I'm going to sneeze. And this is how we're going to convert the bottom of our rate. Excuse me. All right, so that's the trick. First you convert the top, then you convert the bottom. Now look at how we do this. We want to go from seconds to minutes. Seconds are on the bottom, so that means we're going to want seconds on the top. Again, so they cancel, right? It's the same logic as we've used all along. We just have to turn it upside down because we're now working in the denominator, which we've never had a denominator here before. We've only had numbers in the numerator, or units rather. So numbers too, but it's the units that we're working on now. So we do the same thing though. We figure out what we want, how we want to change it, and then we set it up so that the beginning unit will cancel. It means minutes go down here. We ask ourselves the same questions. Which one's bigger, a second or a minute? A minute. It gets the 1. And then we figure out how many seconds are in a minute. 60. Seconds cancel. Now we're all set up to do our next conversion to go from minutes to hours. Minutes are on the bottom, so we'll write minutes up here. Hours go down here. Which is bigger, an hour? It gets the 1, and once again, 60 minutes in an hour. Now the minutes cancel, and look, we're right where we want to be. Hot diggity. I enjoy that very much. And you know, don't you say hot diggity when you're excited? I do. Okay, and so now for our final answer, we're just going to pull all these numbers. John sometimes shows the 1, and I think he's just being a little try hard when he does that. I leave the 1s out. The answer is going to be 42 times 60, and we can write 60 squared, over 12 times 5280, and then we just have 1s there, right? And that will be miles per hour is the best way to write it, okay? We could write MPH, miles per hour, but we don't want to do that. We want to leave our rates in fraction form. Now let's compare our answer to John's. And see, this is what John does. Look, he puts in the 1s and he doesn't use exponents. But there's a 42 and there's a pair of 60s. That's what we have. Miles. And then on the bottom, look, 1, 12, 5280, more 1s, hour. So ours is better than John's. Sorry, John, no offense. And then he says if we use a calculator to multiply and divide and then round the answer to 2 decimal places, that's what we get, which I think is just interesting. That we were going 42 inches per second, which seems really fast, but that only works out to just over 2 miles per hour, which is kind of slow. Okay, let's do another one. Because that was so fun, right? Here we go. Use unit multipliers to convert 480 miles per hour to feet per second. Okay, 480 miles per hour, feet per second. There is rarely a number in the denominator. It's just the rate that's in the denominator. All right, we can do it. So let's map out our first one too. We need to go from miles to feet. Okay, that we can do that in one jump, can't we? We'll go from miles to feet, and then we'll be where we want to be. Then for the time, we'll need to go from hours to minutes, and then from minutes to seconds. All right? On the test, I would like you to set it up just like this. I want to see what your plan is underneath. That's how I think of this. This is the plan of what you're going to do, and then I'll see if you execute it properly. So this is exactly the way I want to see you set it up. All right. We're going from miles to feet. What do we want on the bottom? This is miles, so we want miles down here. Feet up here. Which is bigger, a mile? And this is the one that never fits in the box for me, 5280. Okay, now our miles are canceled. We're at feet, and that's where we want to be. So that's good. Hours. First, we need to go to minutes. We're going to want the hours up here so they cancel. So then minutes will be down here. An hour is bigger, 60 minutes and an hour. Now the hours cancel. And now we need to go from minutes to seconds. Minutes here so they cancel. Seconds, a minute is bigger, 60. I hope that makes sense to you. I always like to see the top converted first and the bottom converted second. Once again, you guys, when you get to maybe chemistry, but for sure physics, you're going to be killing it, and everybody in class is going to want to sit by you because you understand how to do the math. It's fabulous. All right, let's cancel out the last little bit. Minutes cancel. There's our seconds. There's our seconds. Okay, we've got everything the way we want. Now that we have such complex conversions, I don't even try to write my answer up here. I just put it down here when I'm done. All right, don't forget your first number. Sometimes I go and circle it. It's easy to forget that and just be so focused on the numbers in the conversion factors. 480 times 5280. It's not really 52, it's 5,280. 1, forget about it, over 60 squared feet per second. Do you love it? And let's just double check against John's because his looks a little different. 480, 5,280, 1. Forget it, feet. 1, 60, 60. We have 60 squared. Yes. And he uses just the S for seconds. I'm fine with that. But be careful with your abbreviations that you stay accurate because it's easy to get confused. Like M means meters. MI means miles. And MIN means minutes. Make sure you use those accurately so that you're not confusing the person who's looking at your problem, which is going to be me in another week or two. Okay, let's try another. One more of these, and then we're on to the ice cream. You'll be done with your meatloaf. 47.3. Use unit multipliers to convert 15 inches per second to yards per hour. All right. Now, this is one in which John wants us to play dumb. He wants us to pretend that we don't know how many inches are in a yard. And he wants us to do this. Inches to feet. And then feet to yards. And that's perfectly fine if you want to do it that way. But many of us know that there are 36 inches in a yard. So why do we need to do it in 2 steps? And I'm here to say you don't have to. If you can remember how to go from inches directly to yards, then just go in 1 step. Okay, so inches will cancel. Which is bigger? A yard is bigger, and there's 36 inches in a yard. So it's fine to do that in 1 step if you know that number. All right, yards, we're good. Okay, now we need to go from seconds to hours. And again, this is one. If you want to, you can go seconds to minutes, and then minutes to hours. But some people can just remember seconds go up here, hours go down here, and hours bigger. A second is 60 times 60, so it's 3600. That's how many seconds are in an hour, right? 60 seconds times 60 seconds in a minute times 60 minutes is how I got that number, right? So if you can remember that, you can go in 1 jump. And that's going from seconds to hours. All right, so my seconds cancel. I'm left with hours. Yay. So I'm going to say that my answer is 15 times 3,600 over 36, and that's yards per hour. And let's see what John says. Here's his. 15 times 60 times 60 yards over 12 times 3 hours. So we can see right there, 60 times 60, that's how I got that number. And 12 times 3, that's how I got that number. So this is perfectly acceptable as long as you handle the numbers carefully and don't make any goofy mistakes. It's absolutely fine to combine some of these measures into a single jump rather than breaking them down into 2. All right, on to the ice cream. Remember, that was the meatloaf with the vegetables in it. And this is a little update on our friends over in fractional exponentville, which is kind of like Whoville, only everyone is a fractional exponent. Actually, I suppose they're transforming because that's what we're doing. These are trick problems. And once you get the trick down, you're good. Okay, we did things that looked like this before, but the problem is that the bases always matched before. And this time we've got numbers whose bases don't match, and that's a deal breaker, and it ruins the whole problem until we recognize, our little brains turn on, and we recognize that 27 is the same as 3 cubed. So if we rewrite this as 3 cubed, now our bases match and the whole problem works out just fine. So if the numbers inside the pig house don't match, see if you can make them match. That's the trick. So I'm going to rewrite this as the third root of 3 cubed. Okay. Now, I'll go over here. I'm going to go back and forth. Well, I guess I want to use the page well. And then remember, we turn the parentheses into, or the pig house into parentheses. And for the first one, we can put it on the inside. There's no number here, so it must be a 2. Now we are going to turn the outer parentheses, the outer pig house into parentheses. I can't say it right today. 3 to the third times 3 to the 1/2, and then the whole shooting match is raised to the third power. Interesting, right? And now we're ready to distribute. Oh, I'm sorry, to the 1/3. My bad, right? Yes, that's right, because this becomes the bottom of the fraction. Now we distribute this, and we get, I'm going back over here now, 3 times 1/3 is 1, and the other one becomes 1/2 times 1/3, that becomes 1/6. Okay, that's using the power rule. And now we can use the product rule to add them. The denominators need to match. Ones are always easy to convert. We just make it be the same, 6/6. And so our final answer is 3 to the 7/6 power. Okay, that problem was only doable because we realized that even though the bases didn't appear to match, we could make them match. We'll do one more while you decide whether you want sprinkles or not on your ice cream. Here we go. Okay. Here we have the same problem. It's a pig house in a pig house. It's that kind of problem that we're talking about here. The other ones that we were doing, this trick doesn't apply. It's only when you have a pig house and a pig house. The bases have to match. If they don't, see if you can make them match. And we realize that 4 is, oh, I'm sorry, this shouldn't be like this. That's not what I'm thinking of. It's 2 squared. So I'm going to rewrite it as take the 6th root of 2 squared times the square root of 2. That's a lot of 2's flying around, isn't it? All right. Turn the pig house into parentheses. The first fractional exponent we can put inside the parentheses because the base is nice and simple. Now turn the second pig house to parentheses. The number in the corner becomes the denominator. Okay, beautiful. We're ready for the power rule, which is multiplying. And we get 2 to the 2/6, which I'm going to change. I'll just leave it as 2/6. And then this becomes 2 to the 1/12, right? And then we want to add, now we're ready to use the product rule because we're multiplying matching bases. We add the exponents and we'll multiply this one by 2 over 2, right? And make it become 4 over 12. And then 2 to the 5 over 12. That's an exponent. If we are doing a problem like this on the test, make sure your exponents are to scale. And what I mean by that, I'll show you. I want your answer to look like that. I don't want your answer to look like that. Okay? This looks like an exponent. This looks like a mixed number. I can be tough, you guys. I try to be, focused on the learning all the way through. But there's certain things that you really have to get right. And one of them is learning to make your exponents to scale so that your intent is clear. This is clearly an exponent. This looks like a mixed number. You see my point. Okay, that is the end of lesson 47. You have learned the trick. Make the bases match if you see a problem like that. But this is the best advice I gave you in this whole half a lesson is please make sure your exponents are drawn to scale so I can tell what they are. Okay, I will see you for lesson 48, and that will be our last new lesson before Christmas. Hallelujah. Goodbye.